Hi, in this video we're going to look at how to specify MiTek Posi-Joists inside of Autodesk Revit. The first thing you need to do is go to the NBS source website and download the MiTek Posi-Joist family. If you search for MiTek or search for Posi-Joist, should be easy to find on NBS source. When you download it, it will be in a zip file containing two files, an RFA and a text file, which you extract into a folder on your machine. The text file is very important because that is the type catalogue containing the predefined sizes that Posi-Joists are available in. Okay, so I'm going to use the Autodesk Revit basic structural sample project to demonstrate how to use them. And I'm going to go to a 3D view and insert menu and load family and load the RFA file and choose the sizes that you want. So I'm going to go for 253 72mm wide joist, which is what we call a PS10, a 10-inch, and I'm also going to go for the PS12 72mm wide as well, which is 304mm deep. With those loaded, the first thing I'm going to show you is how to substitute existing joist families for the MiTek Posi-Joist family. So just noting in this project here we have a mixture of joists available. We have a wood open web generic joist here, and we also have some rectangular lumber joists as well. It looks like they're all controlled by beam systems, but I'm going to show you two methods of substituting the joists. The first method is by finding the existing family. Be down here in families, and it will be structural framing, and it will be the wood open web joist, this one here. So I can go and select all instances in the entire project, and then I can simply just pick the size of Posi-Joist that I want. PS12 is the nearest match in this case. Okay, so we can see here we have a collision between the beam supporting the joist and the joist itself. This is where you can use some of the construction properties of the joist, like is top chord supported on the end. If I click that on, you'll see that it removes some of the bottom chord and the end vertical, and that will give you a better support condition for this situation. You can control how far the setback of the bottom chord is trimmed by using the top chord support setback property here. So for example, if I was to change that to 300, you'd see the bottom chord is actually set back by that 300 amount, and that detail is what we call the top chord support condition. So that property is only used when we have the is top chord supported property also enabled. Okay, if we look at the middle of the joist, we'll see that we're lacking some of the webs. That's because Revit's parametrics are not quite as advanced as what we have in the MiTek Premier Posi-Joist software, so we can't always adjust the webbing zones to fully fill each zone, but we do have some properties that help fill all the voids available. So I could, for example, uncheck the has additional strong back in the middle to remove that middle vertical, and I could do something like has a chase opening, enable that one, and back in the dimensions set the chase opening length to around 600 millimeters in this case here, and that would give you a central duct opening. Now we still have a little bit of a gap in the webbing. To help with that, you could do has additional web in the middle, and that will give you another single web coming back from the chase opening down, and that would give you a more acceptable layout of the posi webs. So as I say, we can't do all the web configurations that are possible in our engineering software Premiere, but we can have a good go at making a sensible webbing zone using the properties available in the construction section and dimensions when you have a posi joist selected. Okay, so going on to the softwood beam systems here. So rather than substituting the actual joists themselves, this time I'm going to show you how you might be able to just select a beam system and change it to use posi joists instead. So here we just have a property, a beam type property, where we can pick the size of posi joist that we want, and the beam system is updated automatically. Now in this sample project, some of the beam systems seem to work better than others. If I try the same thing on this one, we can see the joist is the correct length. This beam system here, for reasons I don't fully understand, seems to have a cutback. So if I edit the boundary of this beam system and reset the system, we seem to then get the correct length. And it's just a matter of, as I've shown you before, choosing the appropriate support condition. So we can have the top chord supported detail would work much better on this project. Okay, so another example of how we might want to do the webbing, we could again remove the strong back vertical in the middle and tick on has additional web in the middle, and it would put an inverted web in the center of the joist to fully fill those voids. So there's lots of options with posi joists how you web them. You're really only going to get the best answer by using the MiTek Premiere engineering software, but this gives you a reasonable chance of generating a valid looking posi joist. Okay, so the last thing to cover is the manual input, which is just the same as drawing any beam. We can just go to our structure and draw a beam, and then we can choose the size that we want and just draw the joist in between 2 points. Okay, and you'll see it works exactly as the other ones do. We have the various options for top chord support, we can see it more easily here, and having additional webs in the center trying to get the the optimal web layout for this joist. So it's not always that easy. Just play around with the options, see which one looks best. So that's probably the best option for that particular span of joist. Okay, and that's all there is to it. Thank you.